we are going to take a look at some basic terminology, calculations, and drawings we'll use for the rest of stats. By the end of the lesson, you should be able to define all of these, calculate, and draw. Alright, welcome to Lake Tranquil. As of right now, there are a total of 11 houses on Lake Tranquil. You are doing a news report and you want to talk about the income levels of this town. So what we do, since it's a small town, we're going to go from door to door and we're going to ask everyone how much they make. And what I did is we compiled the 11 houses listed in this table right here. The first thing we should do is we should find a mean. And a mean is an average or a balance point. To find this, what you need to do is you need to add up 32,000, 34,000, 42,000, and notice I'm just going to go along and I'm going to add up all of these numbers. I'm going to put ... 36,500. Add up all those numbers and your total sum is 404,500. There's your total sum. Because we have 11 houses, we need to then divide by the total number of incomes we had, and we get our mean at 36,772 and 73 cents. So the mean is just the average. To find the median, we're going to have to rearrange this data because the median is the middle number. So I conveniently rearrange. So what I'm going to do is just look at the middle number. So I'm going to keep crossing out until I get there. And sure enough, because it's 11 families, 5 on bottom, 5 on top, the middle number, the median, is $36,500. And notice that our median is very close to the mean. The mode is the most frequent number here, and if you look at that, it occurs once. 34,000 only occurs once. This occurs twice. All the rest of them only occur once. So the mode here is 35,000. So if I'm a newspaper reporter and I want to report, I could use the mean or the median here. Why? Because they're both very, very close in value. I mean, they're about roughly 200 and some odd dollars off. So either the mean or the median would work. Now, and if you look at our little table, this is called a dot plot, where each dot represents one household, and this is what the spread is like. Now, we have 3 new people move into Lake Tranquil. What happens? We all know that these are celebrities and the income level is going to change. And if you look at the bottom, we have 3 new incomes, 1.5 million, 3.5 million, and $12 million. So what we're going to have to do is we're going to have to add up all these numbers again, etc., all the way up to $12 million. And my new sum is quite large. and now I'm dividing by the total number of households. Since 3 new people moved in, we have 3 new households, so I'm going to divide by 4, or 14, my apologies, and you get a new mean of $1,243,178 approximately. So our mean has gone up. To find the new median, what we're going to do is we're going to kind of go the same way since our data is listed in ascending order. So remember, I'm looking for the middle number. Now I got 2 middle numbers there. So to find the median here, I have to take the average of these 2 numbers. And if I do that, my median is 37,500. Notice my mean and my median are very far apart now. And if we take a look at the plot of this, notice that my computer wouldn't even show the data. We got 12 million here, 3.5 and 1.5, and the rest of the people are in the thousands. So if you're a news reporter now, what number are you sending out? Are you saying the average, are you telling everyone the average income is about 1.2 million? Are you telling them the median income is $37,500? This number, the mean, I would not use for a report. You're going to stick to the median. Why are we going to do that? We're going to do that because the mean is influenced by outliers. Therefore, the mean is not resistant, meaning the mean is going to be affected by numbers outside a normal range, where the median is not influenced by outliers, so the median is resistant. So here, the median is a better stat. Finally, to end this tutorial, I want to show you 2 things. Skewed left, and it's sometimes called negatively skewed. When you're looking at a skewed left, its data is more left of center, and you usually have a long tail on the left side. And a good example of skewed left would be retirement age. Normally people cluster up into the mid to late 60s, possibly early 70s, as you could tell by our data. But look at some of these points that are way to the left. So if I were to try to draw a curve to match my data, notice this long tail on the left side. This would be a skewed left example. Skewed right, sometimes called positively skewed, is going to have more data that falls to the right of center, and it's going to have a long tail to the right. And a great example of skewed to the right would be house prices in thousands. Most houses here in Durango cluster around 200, 300, 400,000, but you're going to get some of those houses that are just ridiculously expensive. And if we were to try to draw a curve for this, we end up something like that. And notice that long tail to the right. You guys should be able to define all of those and calculate mean, median, not too much algebra there, and draw some pictures.